Hello friends, welcome to Sapna's Homeschooling channel. Friends, today we are going to see 10 Science and Technology Part 1, First Lesson Gravitation Exercise. Study the entries in the following table and rewrite them putting the connected items in a single row. First, mass, weight, acceleration due to gravity, gravitational constant. So this is a question. Answers. Mass is equal to kg is equal to measure of inertia. Second, weight Newton and depends on height. Acceleration due to gravity, mass square, 0 at the center of the earth. And fourth is gravitational constant is equal to nm square into kg square is equal to same in the entire. Second question, answer the following questions. A. What is the difference between mass and weight of an object? Will the mass and weight of an object on the earth be the same as the value on mass, and why? Answer. The mass of an object is the amount of matter present in it. It is same everywhere in the universe and is never zero. It is a scalar quantity and its SI unit is kg. The weight of an object is the force with which the earth or any other planet, moon, star attracts it. It is directed towards the center of the earth. The weight of an object is different at different places on the earth. It is 0 at the Earth's center. It is a vector quantity and its SI unit is Newton. The magnitude of weight is equal to mg. The mass of an object will be the same on the Earth and mass, but the weight will not be the same because the value of g on mass is different from that on the Earth. B. What are free fall, acceleration due to gravity, escape velocity, and centripetal force? Answer. Free fall. Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Second, acceleration due to gravity. The acceleration produced in a body due to the gravitational force of the earth is called the acceleration due to gravity. Note, on the earth's surface, the value of the acceleration due to gravity is almost uniform. If a body falls from a low altitude, the value of acceleration due to gravity is almost the same. Third, escape velocity. When the body is thrown vertically upward from the surface of the earth, the minimum initial velocity of the body for which the body is able to overcome the downward pull by the earth can escape the earth forever is called the escape velocity. Fourth, centripetal force. In uniform circular motion of a body, the force acting on the body is directed towards the center of the circle. The force is called centripetal force. C. Write the three laws given by Kepler. How did they help Newton to arrive at the inverse square law of gravity? Kepler's first law. The orbit of a planet is an ellipse with the sun at one of force. Figure 1.4 shows the elliptical orbit of a planet revolving around the sun. Kepler's second law. The line joining the planet and the sun sweeps equal areas in equal intervals of time. A to B, C to D, and E to F are the displacements of the planet in equal intervals of time. The straight lines AS, CS, and ES sweep equal areas in equal interval of times. Area ASB is equal to area CSG is equal to area ESF. Kepler's third law. The square of the period of revolution of a planet around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Thus, if r is average distance of the planet from the sun and t is its period of revolution, then t square alpha r square, example t square upon r cube is equal to constant is equal to k. For simplicity, we shall assume the orbit to be a circle. In figure 1.6, S denotes the position of the sun, P denotes the position of the planet at given instant, and R denotes the radius of the orbit is equal to the distance of the planet from the sun. Here, the speed of the planet is uniform. V is equal to circumference of the circle upon period of revolution of the planet is equal to 2 pi r upon t. If m is the mass of a planet, then centripetal force exerted on the planet by a sun is equal to gravitational force. F is equal to mv square upon r. Thus, F is equal to m in bracket 2 pi r into t square upon r is equal to 4 pi r square mr square upon t square r is equal to 4 pi r mr upon t square. According to Kepler's third law, t square is equal to kr cube is equal to f is equal to 4 pi square mr upon kr cube is equal to 4 pi square m upon k into 1 upon r square. Thus, 4 alpha 1 upon r square as 4 pi square m upon k is constant in a particular case. D. A stone thrown vertically upward with initial velocity u reaches a height h before coming down. Show that the time taken to go up is same as the time taken to come down. We have v is equal to u plus at is the first equation, and s is equal to ut plus half at square is the second equation, is equal to s is equal to in bracket v minus at into t plus half at square is equal to vt minus at square plus half at square is equal to s is equal to vt minus half at square is the third equation. Here we can see figure 1.11. A to B the stone moves upward, B to A the stone moves downward. As the stone moves upward from A to B, S is equal to AB is equal to H, T is equal to T1, A is equal to minus G, retardation, and U is equal to U and V is equal to 0. So from equation 3, H is equal to 0 minus half of minus G T1 square is equal to H is equal to half GT1 square is the fourth equation. As the stones moves downward from B to A, T is equal to T2, U is equal to 0, S is equal to H and A is equal to G. That's why from equation 2, H is equal to half of GT square is the fifth equation, and from equation 4 and 5, T1 square is equal to T2 square. That's why T1 is equal to T2 from T1 and T2 are positive. E. If the value of G suddenly becomes twice its value, it will become 2 times more difficult to pull a heavy object along the floor. And why? Answer. To pull an object along the floor, it is necessary to do work against the force of friction between the object and the surface of the floor. This force of friction is proportional to the weight mg of the object. If the value of G becomes twice its value, the weight of the object and hence the force of friction will become double. Therefore, it will become 2 times more difficult to pull a heavy object along the floor. Third question. Explain why the value of G is 0 at the center of the earth. Answer. The value of G changes while it's going deep inside the earth. It goes on decreasing as we go from the earth's surface towards the earth's center. We shall treat the earth as a sphere of uniform density. If we consider a particle of mass m at point P at a distance with r minus d from the earth's center, where r is the radius of the earth and d is the depth below the earth's surface, the gravitational force on a particle due to the earth is F is equal to gmm dash upon r minus d square dash. M is equal to 4 upon 3 pi r minus d cube into m upon 4 upon 3 pi r cube is equal to m r in bracket r minus d cube upon r cube. Because the outer spherical shell is not effective, figure 1.10 in this case, the acceleration due to gravity is where m is the mass of the earth. Thus, g decreases as d increases. It is less than that at the earth's surface. In bracket gm upon r square at the earth's center, d is equal to r. That's why g is equal to 0. Question number 4. Let the period of revolution of a planet at a distance r from a star be t. Prove that if it was at a distance of 2r from the star, its period of revolution will be 8 in root t. Answer. T is equal to 2 pi upon in root gm r cube into 2 where t is equal to period of revolution of a planet around the sun, m is equal to mass of the sun, g is equal to gravitational constant, and r is equal to radius of the orbit assumed to be circular is equal to distance of the planet from the sun. For r is equal to r and t is equal to t1. So this is the derivation. That's why T1 is equal to 2 pi upon in root gm r cube into square. For r is equal to 2r and t is equal to t2. That's why t2 is equal to 2 pi upon root gm in bracket 2r 3 square 3 into 2 is equal to 2 pi upon in root gm r 3 into 2 in 2 root 3 into 2 is equal to t1 into 2 root 3 into 2. That's why t2 is equal to t1 root 8 is equal to 8t. Fifth question, solve the following examples. A. An object takes 5 seconds to reach the ground from a height of 5 meter on a planet. What is the value of g on the planet? Solution. Data. U is equal to 0 ms and s is equal to 5 meter, t is equal to 5 seconds, g is equal to what? So look, answer is, that's why s is equal to 1 half gt square. That's why 5m is equal to half g into 5 second square is equal to half g into 5s into 5s. That's why g is equal to 2 upon 5 ms square is equal to 0.4 ms square on the planet. B. The radius of a planet A is half the radius of planet B. If the mass of A is ma, what must be the mass of B so that the value of G on B is half that its value on A? Practice activity sheet 4. Data. RA is equal to RB into 2. GB is equal to half of GA. So MB is equal to what? G is equal to GM upon R square. That's why GA is equal to GMA upon R square A, RA square, and GB is equal to GMB upon RB square. That's why GB upon GA is equal to MB upon MA in bracket and into in bracket RA upon RB square. That's why. So GB upon GA is its mean half is equal to in bracket MB upon MA into 1 upon 2 square is equal to 1 upon 4 in bracket MB upon MA. That's why MB upon MA is equal to 4 upon 2 is equal to 2. So MB is equal to 2 MA. See, the mass and weight of an object on the earth are 5 kg and 49 Newton respectively. What will be their values on the moon? Assume that the acceleration due to gravity on the moon is one of the sixth of that on the earth. Solution. Data. M is equal to 5 kg, W is equal to 49 Newton, Gm is equal to Ge upon 6m. On the moon is equal to what? And W on the moon is equal to what? First, the mass of the object on the moon is equal to mass of the object on the earth is equal to 5 kg. Second, W is equal to mg. So that's why Wm upon W is equal to mgm upon mge is equal to gm upon ge is equal to 1 upon 6. So Wm upon Wm is equal to We upon 6 is equal to 49 Newton upon 6 is equal to 8.167 Newton. D. An object thrown vertically upwards reaches a height of 500 meter. What was its initial velocity? How long will the object take to come back to the earth? Assume G is equal to 10 ms square. Solution. 100 ms square and 20 seconds. E. A ball falls off a table and reaches the ground in 1 second. Assuming G is equal to 10 minute per second square, calculating its speed on reaching the ground and the height of the table. Solution. Data is equal to T upon T is equal to 1 second and G is equal to 10 ms square and U is equal to 0 ms square. S is equal to what and V is equal to what? So solution. First, S is equal to ut plus half gt square is equal to half gt square for U is equal to 0 ms That's why S is equal to half into 10 ms square into 1 second square is equal to 5 meter. The height of the table is 5 meter. Second, V is equal to U plus AT is equal to U plus GT. So, 0 ms plus 10 meter per second square into 1 second is equal to 10 meter per second. So, the velocity of the ball on reaching the ground is equal to 10 meter per second. F. The mass of the earth and the moon are 6 into 20, 10 power of 24 kg and 7.4 into 10 raised to 22 kg respectively. The distance between them is 3.84 into 10 raised to 5 km. Calculate the gravitational force of attraction between the two. Use G is equal to 6.7 into 10 raised to minus 11 nm square into kg square. Solution. Data. M1 is equal to 6 into 10 raised to 24 kg. R is equal to 1.5 into 10 raised to 11 m. F is equal to 3.5 into 10 raised to 22 Newton. G is equal to 6.7 into 10 raised to minus 11 nm square into kg square. So, M2 is equal to what? So, force is equal to Gm1 Gm2 upon R square. That's why M square is equal to Fr square upon Gm1 is equal to 3.5 into 10 raised to 22 Newton. Yes, I was here. Solution. Data is equal to M1 is equal to 6 into 10 raised to 24 kg. M2 is equal to 7.4 into 10 raised to 22 kg. R is equal to 3.84 into 10 raised to 5 km is equal to 3.84 into 10 raised to 8 meter. G is equal to 6.7 into 10 raised to minus 11 nm square into kg square. F is equal to what? So F is equal to Gm1 M2 upon R square is equal to 6.7 into 10 raised to minus 11 nm square into kg square into 6 into 10 raised to 24 kg into 10 raised to into 7.4 into 10 raised to 22 kg upon in bracket 3.84 into 10 raised to 8 meter square is equal to 6.7 into 6 into 7.4 into 10 raised to 35 upon 3.84 into 3.84 into 10 raised to 16 Newton is equal to 2.017 into 10 raised to 20 Newton. This is the magnitude of the gravitational force between the earth and the moon. G. The mass of the earth is 6 into 10 raised to 24 kg. The distance between the earth and the sun is 1.5 into 10 raised to 11 meter. If the gravitational force between the two is 3.5 into 10 raised to 22 Newton, what is the mass of the sun? Use G is equal to 6.7 into 10 raised to 11 nm square into kg square. Solution. Data. M1 is equal to 6 into 10 raised to 24 kg. R is equal to 1.5 into 10 raised to 11 meter. F is equal to 3.5 into 10 raised to 22 Newton. G is equal to 6.7 into 10 raised to 11 nm square into kg square. So, M2 is equal to what? F is equal to Gm1 M2 upon R square. So, that's why M2 is equal to Fr square upon Gm1 is equal to 3.5 into 10 raised to 22 Newton into in bracket 1.5 into 10 raised to 11 meter square upon 6.7 into 10 raised to minus 11 nm square into kg square into 6 into 10 raised to 24 kg is equal to 3.5 into 1.5 into 1.5 into 10 raised to 44 upon 6.7 into 6 into 10 raised to 13 kg is equal to 1.96 into 10 raised to 30 kg mass of the sun. Now the project. Take weights of 5 of your friends. Find out what their weights will be on the moon and the Mars. Answer. Help. The weight of a body. First, on the earth, weight 1 is equal to mg1 means mass gram 1. Second, on the moon, w2 is equal to mg2. Third, on Mars, w3 is equal to mg3. So that's why w2 is equal to w1 into g2 upon g1 and w3 is equal to w1 into g3 upon g1. Now g1 is equal to 9.81 meter per second square and g2 is equal to 1.67 mass minute per second square. and G3 is equal to 3.72 m into s square. If W1 is equal to 500 Newton, W2 is equal to 500 into 1.679 upon 81 Newton is equal to 85.12 Newton approx. And W3 means weight 3 is equal to 500 into 3.7219 upon 81 Newton is equal to 189.6 Newton approx. So this is the optional project. If you want to do, you can do. If you don't want to do, you can't do. So thanks for watching our video. Please subscribe to our channel, like a video, and share it to your friends. Thanks.